Hey everyone, my name is Vale,
Hi, I'm Carlos.
and we'll be presenting to you nuclear submarines. Okay, so to give a little bit of background, we'll look at the history of submarines. The first prototype was designed by William Byrne in 1578. Then, as you can see it pictured at the right, the first navigable submarine was designed by Cornelius Drebbel between 1620 and 1625. Fast forward to 1776, the first military submarine was created and was branded the Turtle by David Bushnell. In the 1800s, the first dual propulsion submarine came to existence. That was designed by Robert Fulton. At last came the 1862 first U.S. Navy submarine, branded the Alligator. Now we'll look at the history of submarines going nuclear. So the United States developed its first nuclear-powered sub and branded it the Nautilus. The first journey it had was on January 21, 1954. This submarine had great maneuverability, unlimited range, and was able to stay underwater for great lengths of time. It needed to resurface every now and then, but could stay underwater for a while. Its impact to the world meant that it radically altered naval strategies, as they could now be underwater for a longer period of time and undetected. The Soviet Union eventually developed their own version of the nuclear submarine.
So next, in order to understand how nuclear submarine works, we have to understand how conventional submarines work. So first of all, the necessities for a normal submarine. The big things that a normal submarine needs is to last long times underwater, evade sonar, radar, and whatever mode of detection that they could be detected by enemies, and move fast. A normal diesel-powered submarine has to snorkel in order to recharge its batteries. In reality, diesel-powered submarines aren't like a normal car with an engine which by combustion moves the motors. What a diesel-powered submarine does is that it has to surface and use the air in order to turn on their motors so that the motors can charge the batteries, which later are used in an electric motor to power the submarine. This is because combustion needs oxygen, and submarines can't just carry oxygen with them. That's why they have to snorkel, turn on their diesel-powered engines, charge their batteries, and then those batteries are then used with an electric motor in order to power the propulsion unit. This has a disadvantage, and is that these batteries are relatively small, as batteries weight a lot and aren't really densely, like energy isn't very dense in batteries. For this reason, the record for a diesel-powered submarine to stay underwater is 18 days, only 18 days. This means that every now and then they had to surface, in which they are really easily detected and attacked because they're in the surface where radar is it's really easy to find them with radar.
Now we need to understand what fission is. There are two ways to create nuclear energy, fission and fusion. But humanity hasn't yet mastered how to use fusion properly. So nuclear submarines run using fission. This is a process where the nucleus of an atom is split and creates many more smaller nuclei. This happens as a neutron is bombarded into the atom, which therefore releases more neutrons that hit more atoms, creating a chain reaction, and therefore energy is created.
So how does fission work? What happens is that atoms are put together by nuclear force. The nuclear force keeps the nucleus together, but there's also the electric force, which wants to repel, because the nucleus has neutrons, which are neutral, and protons, which are positive and want to get as far away as they can from each other. The nuclear force is really strong, but that is only when atoms are small. As the atom gets bigger, the nuclear force gets weaker, and the electric force still gets weaker, but at a slower rate, meaning that eventually the electric force will be so big that it can be bigger than the nuclear force. When this happens, a nucleus is called to be unstable. So when an extra neutron is bombarded into the nucleus, this nucleus will be so unstable that it will split into two, then again causing the chain reaction that Valley mentioned before. So how does a nuclear reactor work? The main point of the nuclear reactor is to heat up water, and this water will then be used in order to spin a turbine, which will create electricity or can go to the propulsion system. In nuclear reactors, they're made of two main things, the core and the heat exchanger. The core has the fuel, which is uranium, the control rods, which are mostly made of boron or cadmium, and these are the ones that control the reaction by entering or retracting, and the moderator, which is the water that goes through the reactor. Then this water, which is really heated up in the core, will go through the heat exchanger as seen in the picture below. How the heat exchanger works is that the water from the core heats up more water, which is called the secondary water, and this water will become steam. This can be seen in the picture below, in which a tube enters a container with water, heats it up, and the steam then goes into another tube, which will eventually move a turbine, and the turbine can be connected so that it can generate electricity, or it can be connected to the propulsion of the submarine.
Okay, now, what is nuclear energy used for? Since nuclear energy is pretty much creating electricity from the energy found in the core of an atom, it is controlled by two main things, nuclear reactors or nuclear power plants. These are the sets of machines that can control nuclear fission. So pretty much nuclear energy is used to run anything that runs with electricity. It's a safer, more eco-friendly way to get energy to run our everyday items. Some examples are power plants, submarines, and aircraft carriers.
So then how does this nuclear submarine work? How they work again is by using a nuclear reactor in order to heat the primary water, which then heats the secondary water and creates steam. The steam then moves and spins turbines, which can be used in order to create electricity for the submarine, or it can be connected directly into the propulsion of the submarine. In order to increase the power, the control rods are removed, and in order to decrease the power, the control rods are inserted. Now, this energy, the nuclear energy, is not only used in order for the propulsion of the submarine. It is also used for all the electronics of the submarine, such as the machine that makes the electrolysis to make the oxygen for the people commanding the submarine, and all the other electric components of the submarine. Usually, nuclear submarines have three operators. One controls the reactor by inserting or decreasing the rods, or just maintaining it, seeing that everything is okay. Then the other controls the propulsion, and they have to have a lot of communication in order to increase and decrease the power. And then the other one controls the electrical system. These three people are in the same room, which can be also modeled in the outside world so that they can train and be really prepared in order to command a nuclear submarine.
Now, what are a nuclear submarine's pros and cons? For the pros, I'm going to start at bottom and say that these submarines are incredibly efficient as they use 1 ton of uranium per year, and they don't need to be refueled for 25 years. Then, these submarines are very fast, going at 37 kilometers per hour, whereas conventional submarines can't go this fast because they lose range, and it becomes an inefficient way to travel. Then another pro is the long duration underwater, which just means that they can last a really long time without resurfacing. Another thing is that they're very silent. They don't have the typical kind of machinery that conventional submarines did, so they don't make that much noise. And lastly, they are a lot bigger. Because they're so efficient, they have the capacity to be bigger in magnitude. The King class submarine is 92.6 meters on average, and the Typhoon class is 175 meters. So you can see the difference between a non-nuclear and a nuclear submarine and how much their size can differ. For the cons, there aren't that many. The submarines leave nuclear waste, which releases radiation and takes a really, really, really long time to stop doing this. Then the next two are concerning the ability of being tracked. They can be detected because of the radiation, and they can be detected because of the trace of hot water that they leave behind. And lastly, they're very expensive since it is such uh, an intense amount of machinery, and they're very big in size, so it becomes very expensive to maintain. Now we're going to look at some fun facts. First one.
So uranium-235, which is the one used for nuclear reactors, is only about 1% of the total mined uranium.
Then fission is the same thing used for nuclear bombs, like hydrogen bombs.
Uranium is the heaviest naturally produced atom.
Then fusion is the ideal energy source, but it hasn't been reproduced efficiently on Earth. It's an optimal way to create energy, and that's why hydrogen bombs use fission to create fusion and become so powerful.
What they do is that they create fission in the outside, so that when the outside bomb explodes, it creates so much pressure that fusion can be created, releasing even more energy.
And last, we have that there was once a project to make a nuclear-powered plane, but it failed because the shielding was too heavy to stay up in the air.
Okay, so lastly, we interviewed someone who was very familiar with nuclear submarines. His name is Mike Short, and he is a nuclear engineer who worked in nuclear submarines. So here are some questions that we asked him and the answers he gave us.
Okay, so we asked him what his job was, and as stated above, he was a nuclear engineer, and he worked in the area of nuclear submarines for the UK Navy.
So we asked how much time did they usually spend in a nuclear submarine as he lived in them. He told us that they would spend approximately 40 days in the ocean. They would never surface, and they would only come back to shore so that they could receive again food supplies, and they could have some rest from being in the claustrophobic environment of a submarine.
Then we asked him what they used to shield the reactor, and he confirmed to us that it was lead.
Then we asked how does the reactor has to be turned off completely at any point. He mentioned that this is impossible, as the control rods can't turn it totally off, and they usually don't put it at its lowest energy. But sometimes when they are at shore, they do have to put the entire rods in. And in order to start the reactor, they have to start it slowly so that they don't poison the reactor.
Then we asked him what was the usual maintenance given to the reactor, and he explained that they didn't usually need to do this because it's a process that runs so smoothly and is worked on very, very much before the submarines go into function, so to speak. And every now and then, maybe every couple of years, they check that the nuclear reactor is in its full working potential.
Then we asked how did they receive food from boats, or did they always go back to shore? He explained, again, as I said, that they only did this in shore and they never surfaced while on sea. The only time when they surfaced was when someone was feeling really sick and a helicopter had to come and pick that person up.
Next, we will show you a clip of Mr. Short introducing himself and giving a little rundown of what his role has been.
And there, it's going.
Okay, hello, hi. My name is Mike Short. I'm a mechanical engineer, I'm a nuclear engineer, and many years ago I served in the Royal Navy, the UK Navy, and served in surface ships and then went to join nuclear submarines. And on board the nuclear submarines, I was a marine engineering officer, and my job was to manage and oversee the operation of the reactor, nuclear power plant, and all the auxiliary equipment on board the submarine. And I spent 4 years doing that. In that time, I went out on many patrols, and I would say that during that time, problems with the reactor itself were minimal, if any. The work we did was mainly around maintaining the submarine overall, all the propulsion equipment, and all the equipment outside the reactor compartment. But it was a great experience. We spent a lot of in simulators, learning the emergency operating procedures and normal operating procedures. So if anything went wrong at sea, we knew exactly what we had to do, how to deal with it. Okay?
Okay, thank you very much.
Okay.
Yeah. Okay, so that ends our presentation. I hope you learned a lot about nuclear submarines. If you have any questions, please, you can ask us and we will gladly respond. And yeah, thank you. That's it.
Yeah, thank you so much.